Um, yeah, so as noted, I am Dr. Joey Hinton. I'm the senior research scientist at the Wolf Conservation Center. Today, I'm just going to give you guys a presentation on how coyotes are managed in North Carolina for red wolf recovery. There's some interest when I was at TWS this year in Baltimore. I bumped into Stephanie, a few other folks who were interested in how coyotes are managed because the U.S. Fish and Wildlife Service, when they are managing coyotes out there, use sterilization to prevent introgression into the red wolf population. And so they've been doing this since 2000. It's part of their adaptive management plan. I've worked with them as in a research capacity since my intern days in 2002. Did some field work out there as a field tech through University of Tennessee, working with them in black bears. Then did my master's and then my PhD work. So from 2002 to about 2012, I probably spent about 6 years in the field with their biologists, working with them directly, doing things like radio monitoring animals, capturing and radio tagging them or radio marking them and whatnot. And I got a chance to see how they manage coyotes and wolves directly out there. And so that's influenced a lot of my research over the years. And interestingly, anytime we publish any of that coyote data from the North Carolina area, the 5-county area, we routinely in the methods section note that the animals are sterile and that there's a sterilization program there. And it usually flies under the radar, and people usually don't, ask many questions about it. It wasn't until I bumped into Stephanie and Giovanna at TWS that there was some interest in this from some other folks. And so hopefully this winds up being useful for folks here. So as noted here, the title of the slide or the talk is going to be use of fertility control for coyotes under federal management for red wolf recovery. And what that means is basically when the recovery program or the Fish and Wildlife Service captures a coyote out there, they sterilize it, radio mark it, and put it back out. They monitor it. They basically manage it, but that comes through permits with the state agency. So it's not that the coyotes out there are under federal control, but they are still state trusted resources or whatever. So the state has control of the coyotes. The Fish and Wildlife Service goes ahead and gets permits to do this management. So it's something that they do in collaboration with the state agency. But before we get into this stuff, I want to go over some history with the red wolves and what they are exactly. So here on this slide, some noise here, is a lot going on here, but I'll walk you through it. So this is a figure from a paper that we have in review right now, covering the red wolf's extirpation from Alabama. The panel on the left here shows the red wolf's historical range prior to European colonization of North America. And so you can see that in most of the eastern U.S., was where the red wolf was historically found at. Of course, we extirpated them. The reason why Alabama is outlined here on the map is because that particular study is focused on Alabama and the extirpation of the wolf there. Here we're highlighting in this panel here, B, where you see these spelunkers, we're highlighting the Fern Cave specimen. The Fern Cave specimen is a wolf that was found by cavers in the late 60s, it's a fully complete skeleton. It's the only fully complete skeleton of a red wolf that we have historically or paleontologically. It even came with like a baculum, so we know it was a male. And so this wolf, we have full measurements on it, and it's representative of the historical wolf that would have occupied most of the eastern U.S. And so when we compare that wolf to wolves that were killed in this region during the early 1900s when the populations were really declining, it's the same wolf phenotypically, meaning that these wolves that early Americans killed at the turn of the 20th century, it's the same animal. There's good continuity between their morphology. Once the red wolf's historical range or geographic range was restricted to a few counties and parishes in Southwest Louisiana and Southeast Texas along the Gulf of Mexico, here, the recovery program started, and there was an effort to capture the last remaining red wolves that they knew existed down there and put into a captive breeding program. This is a photo of a red wolf that was captured in Johnson Bayou in Cameron Parish and was used as one of the founders. So it was shipped out to Point Defiance Zoo in Tacoma, Washington to start the captive breeding program. even though these animals were pulled out of a known hybrid swarm and were suspected to have some coyote introgression in them, meaning that genetically they would be different than your historical red wolves because of that genetic introgression. Morphometrically, this animal is very similar to the animals they were killing a few decades beforehand, and very similar to the animals that they were finding, in the caves and across these sort of historical excavation sites, where they found historical specimens. And so we know those animals that we started the captive breeding program with there's good continuity with their morphometrics. And then those animals, the progeny of those animals were released into northeastern North Carolina in '87 and have been maintained out there as a small reintroduced population since then. And this is a photo of a female that I caught and collared and released as a PhD student. And this animal's morphology is very similar to the fern cave specimen, meaning that the animals that they're managing and reintroducing into the wild in North Carolina are very similar to the historical wolf populations across the eastern US. And so there's been some, I'm not going to get into the taxonomy, but there's been some questions about the wolf's genetics and whether it was a hybrid or not. That was a recently created through gray wolf hybrid or gray wolf coyote hybridization. That's been debunked. It's not the case. Red wolves are closely related to coyotes, which is why they have some phenotypic affinity to them. But for the most part, they're phenotypically different, and they represent basically what was the historical wolf here in the eastern US. And so that's what we have in North Carolina. So with the coyotes expanding, cover that really quick too. This map is a map from a paper that we published a few years ago, covering the coyotes' geographic range in North America, looking at the differences in their morphology and their genetics. This red area that's hatched in is their historical range at the time Europeans settled in North America. The other different colored hatch areas represent different range expansions since then. The first range expansion was assumed to happen when the Spanish started colonizing Mexico and converting forest into rangelands and agriculture. So coyote populations in central Mexico and parts of southern Mexico moved south into Central America and began occupying that region. Some researchers from that area, from Central America, have suggested that's not the case, that coyotes may have always been there. They just occurred there at very low abundances. But the conversion from, natural, forested areas to open agriculture, livestock pastures, allowed coyotes to increase in abundance, which gives the impression that they might have colonized the region. So this is still questionable, but for now, it's the first front. The second front happened in the mid-1800s, going into the early 1900s, during the gold rushes into Alaska. So you start seeing coyotes move through the Northwest Territories of Canada and then eventually into US Alaska there. And they did that, in the presence of gray wolves and without hybridization. Of course, down here, they supposedly colonized in the absence of gray wolves. There's no gray wolves down there. There's no wolf populations in Central America. And then finally, the more recent colonization fronts that we know of is coming into the eastern US. There's three particular fronts that we know of. One is going north of the Great Lakes into, I guess, southeastern Canada, and coming into the northeastern part of the US. A second front hit south of the Great Lakes through Ohio, Indiana, into Pennsylvania, and they eventually met with that northern front across the Great Lakes. This northern front is known to have hybridized with eastern wolves, and so those coyotes, as they came into New York, Vermont, Maine, were heavily introgressed with, eastern wolf genetics. This population coming from the south was not introgressed all that much because there was no populations of eastern or red wolves down there. And so when they merged here, there was admixture. And so the northeastern populations assumed to be a strongly admixed population with wolves that carry about 25% wolf genetics. And then you have the southern population here, which I'll go more into in a second. This is the population that moved through the Gulf Coast and into the southeast and eventually met with the northern population around the Virginia area of the mid-Atlantic. These two areas or where hybridization occurred. So as I mentioned, this northern front admixed with eastern wolves, and the southern front is where they hybridized and admixed with red wolves. And the southern front is really well documented. There's papers from Fish and Wildlife Service biologists in Oklahoma noting that for the first time they were seeing black coyotes occur, and it was resulting from those coyotes replacing red wolves in areas where red wolves were extirpated and outbreeding with the last remaining black red wolves or melanistic red wolves. And so this front is actually well documented. It's just not it just doesn't carry, I guess, the public's attention like the Northeastern front did. One thing to note, like I mentioned here, this first front went into Central America. No wolves. The second front went into Northwest Alaska or Northwest Canada and into Alaska. There were gray wolves there and no hybridization, but it was the extirpation of eastern wolves and red wolves that allowed coyotes to come east, and that's where we do see hybridization. And so basically, you had this historic population of red wolves along the Mississippi River Basin that was preventing coyotes from coming into the southeast. It wasn't until they were extirpated that coyotes could come to the southeast. So it's important when you say when wolves are extirpated that allowed coyotes to colonize an area, it's important to note that it was red wolves and not gray wolves. They do find coexisting with gray wolves, as you can see in the Midwest and Canada and Alaska and whatnot. The other thing too is in some areas of the U.S., wolves were extirpated for decades, if not like a century before coyotes moved in. So we did help them quite a bit through deforestation and draining wetlands and establishing road networks that made some of those areas accessible. So after wolves were extirpated, those land changes also provided an opportunity for those coyotes to move across. And of course, with wildlife management and reestablishing a lot of our game populations throughout the eastern U.S. During the 1930s, 40s, 50s, 60s, and so on, it provided an ample prey base for coyotes to take advantage of. In the case of white-tailed deer, that seems to be an important prey item for eastern coyotes. So reestablishing their populations throughout the east during the 50s and 60s, along with the habitat changes and the absence of red wolves, it's not a coincidence that coyotes started popping up in the 70s and 80s in a lot of spots. And so that covers, how coyotes got here and why we're trying to manage them, I suppose, in many situations. So going back to this figure, so I'm going to cover how we got these Texas, Louisiana red wolves into North Carolina. As I mentioned, the recovery program had caught the last few remaining known wolves that they were aware of out there and put them into a captive breeding program. And the progeny from that captive breeding program was used to start this site in North Carolina. So again, we'll cover that. One of the things you notice here is this range map is a little different than the one I presented right here. That's because this is what I interpret being the red wolf's historical range, and it's based off NOAC's 2002 paper. This range right here is what the U.S. Fish and Wildlife Service recognizes. And this is their position on the red wolf's historical range. So make that clear. And so what I want to show here is two plates. This is a drawing of red wolves. It's plate 1 in the wolves of North America, and plate 2 is a photo of a Texas red wolf. So the wolves of North America is like a seminal book that was written, almost a century ago, detailing, all the wolves in North America. And the very first two figures in the book are red wolves. And I think that's a result of, at that time period, there was a strong core population of them in the Mississippi River Basin and along the Gulf Coast here. And so researchers back then would have been aware of the red wolf and known about them. And of course, you would have had gray wolf populations elsewhere. But today, it's not the case because red wolves are gone. We just have a small population in eastern North Carolina. And so I think it's a situation of where you have, what is it called? The shifting baseline scenario, where our expectations of what a wolf community looks like in the U.S. is a bit changed by today's generations, or the expectations are a bit lower because we don't have this large core area of red wolves anymore. So anyway, here's some photos of some red wolves that we had during the early 1900s. This is from Audubon's book. So when Audubon was down in Florida, he came across black red wolves. Black wolves were common in the Southeast. He documented that. This is a black red wolf, or a melanistic red wolf, that was caught in Tensas River area of Louisiana. A photo there, so you can see the similarity between what Audubon drew and the photo of this black wolf. And this is another red wolf that was captured in Louisiana, or maybe Arkansas. It might have been southern Arkansas, I'm not sure. But either way, these are photos of historic wolves that were caught back in the 30s and 40s. There's photos of them back taken in the 20s and whatnot. I'll show some of those here in a few minutes. So as I mentioned, by the time you get to the 40s, you have this core population of red wolves in what I refer to as the Mississippi River Basin and the Gulf Coast. By the time you get to the 60s and 70s, that population is reduced to a handful of individuals in some remote counties and parishes along the Gulf Coast there in Louisiana and Texas. And we got there because of these predator control programs. Around 1915, the federal government started passing federal, I guess, bills to fund and support predator control programs, and the states took advantage of that. And so the wolf's range was greatly restricted and reduced to this area due to federal efforts to exterminate them. And you can see here, this is a wolf from, I think, the 1920s and the 1930s. That's a big animal that was killed. And these are wolves taken in 47 and 62 in the papers and whatnot. And so, yeah, lots of killing of wolves at that period. So no shock that you had that reduction there. Here's a situation where the locals even realized it. This is an editorial or letter to the editor written by somebody in Chambers County, Texas. And so in Eastern Texas, they didn't have coyotes. And people would note that. It's in a lot of the records where we don't have coyotes, we have a wolf. And as they realized these bigger canids were disappearing, they were being replaced by these smaller canids that were coming in from Central Texas and whatnot. So it was noticeable, even to normal people, like everyday folks out there in the 60s and 70s, that the red wolf was sort of disappearing and being replaced by coyotes. Louisiana was the last stronghold for the red wolf, and its extirpation there is quite well documented. Ron Nowak wrote an article about it to Defenders of Wildlife about 60 years ago. And so basically, the core population in Louisiana ran across the central part of the state from the coast up into Tinsall River. The first area to get snuffed of its wolves was the northwest corner of Louisiana, and that, of course, allowed coyotes from Texas and Arkansas to start moving into the state. Eventually, Tinsall River down into the center part of the state. Those populations were extirpated, and that allowed the coyotes to keep moving into Mississippi and Alabama, north into Arkansas and elsewhere. This population along the Gulf Coast in Cameron Parish and Calcasieu Parish stayed, and so the coyotes just sort of washed over them with animals moving in, and they had some hybridization problems going on there with the last remaining red wolves. And so that's where, that's basically how these coyotes picked up that red wolf genetic material, was through, basically outbreeding with the last remaining red wolves that were there that couldn't find other red wolves. And so in 1973, with the passage of the Endangered Species Act, the red wolf was listed as an endangered species, and the U.S. Fish and Wildlife Service created the Red Wolf Recovery Program. It was initiated and I guess started in Beaumont, Texas. So that I think is under Region 2 of the U.S. Fish and Wildlife Service. Now, now the Red Wolf Recovery Program is at a Region 4 based out of Atlanta because they're in North Carolina. So anyway, that's just some administrative stuff. Anyway, recovery programs initiated. After about a year or two, they had realized that there was no way that they could, I guess, preserve the red wolf in perpetuity down there along the Gulf Coast. They realized that they would have to go out and catch some of the last remaining wolves and start a captive breeding program with them to save the animal from extinction. And so they did surveys, and this is here on the left is a figure of a density map, I guess, of where or distribution of where they thought red wolves were. Areas that are X'd up here, low density red wolves, high density red wolves along the coast here. This is Chambers County. You come over towards Houston. Houston's over here. You start getting into more coyotes and hybrids. And so they would go into these areas where they had suspected to be high density or low density red wolf occurrence and trap them. And they were catching hundreds of animals, and a number of them were wolves. So you can see here, there's a wolf here that was captured. Here's Curtis Carley, the first red wolf recovery team leader down there with a wolf. This is James Shaw. He was a PhD student who helped out prior to these efforts. He did his PhD down there, I think before 73, 74, late 60s. Anyway, just showing that photo off, just showing some red wolves. So here's handwritten notes of the tallies from Curtis Carley of what was captured down there. You can see within a designated area that they felt was where the core area of the red wolves were, they had caught 465 canids, and they had 55 of them were red wolves, or assumed to be red wolves. And of course, outside that, they had some in surrounding areas that they weren't focused on, but still were able to trap, or other people had caught animals and called them, and they came out and got them. They added another 7 wolves to their total. So they had handled what they thought were 62 red wolves. And here's some photos of some of those animals here. And as I mentioned, this is your typical red wolf. And this animal is very similar to what I mentioned in terms of the morphometrics of the animals that were historically found throughout the eastern US. No difference between these and any of the bones that you dig up, in Virginia or North Carolina or Louisiana or Texas from or East Texas from 5,000 years ago or so. Anyway, these guys were used to start the captive breeding program. And as I mentioned, there's 62 here. Not all of these animals went into the captive breeding program. I think about 27 or 30 of them were radio marked and released back out into the wild. This guy was released back out. You can see his radio collar right there. And they were kind of used as a Judas animal, but not in a bad way. They were using them to help figure out where the packs were so they could go in and find the other remaining wolves and get them up too. So that left about 45 or so animals that were shipped up to Point Defiance Zoo. And I think a handful of the animals died in transiency or whatever, in shipment. And then some animals didn't breed. And eventually you have 14 founders from those 62 animals that are representative or the reason why we have all the wolves we have today currently. And so in 1987, the progeny of those animals captured along the Gulf Coast was used to initiate the red wolf reintroduction site in eastern North Carolina on the Albemarle Peninsula. It was started at Alligator River National Wildlife Refuge. And so that's what you're seeing here is this is some of the first animals being pulled out for release at Milltail. This is one of the more recent animals out there. I think this photo was taken about 3 or 4 years ago at Milltail. Milltail is where is the pack on Alligator River. That is the founding pack that's been out there since 87, 88. So this is the 5-county area or the Albemarle Peninsula where the reintroduction site is carried out right now in eastern North Carolina. And so you can see it's not a highly fragmented landscape compared to out in this area. You don't see that yet. Large contiguous tracts of coastal bottomland, which is usually wildlife refuges under the management of the United States Fish and Wildlife Service. These dark green areas are usually loblolly pine plantations. They're usually belonging to Weyerhaeuser, an international timber company. And then what's tan are usually agriculture, and those are usually either corporate or individually owned by people who live out there. And so yeah, it's basically a large agricultural coastal bottomland forest landscape. This is what it looks like, from the air, satellite or whatever. Like I said, you can see lots of contiguous habitat here. Once you come out of the 5-county area, more fragmented. Right there is what I call Milltail all the time. That's not the proper name for it. This is actually Alligator River National Wildlife Refuge. That agriculture there is agriculture that they have out for the wildlife. They have tenant farmers that farm that, and I think like 15% or so of that agriculture is left behind for migratory birds and other wildlife. But the wolves benefit from it. The main road coming in is called Milltail, and since the pack is near Milltail, it's called Milltail. And so I refer to this as Milltail, but it's actually Alligator River National Wildlife Refuge. South of it is the bombing range for the Air Force. Okay. This is where the founder pack was established. This is where the wolves were initially released in North Carolina. This is what it looks like. I think this is where the den block is, and this is the open agricultural area at the refuge. Next to it is the Dare County landfill, and to the south of it, as I mentioned, is an Air Force bombing range. So this is the first reintroduction of wolves into the wild in the lower 48. The wolves were extirpated completely from the wild, and we did it near a landfill north of the bombing range. So not really Yellowstone sort of situation, but you do what you can with what you have. So showing that here, going back here, the idea here is you put the wolves out here, they're going to start breeding, and then they're going to start expanding out from that area. And as you can see, they only go south, which is what they did. Eventually, they grab some turf, down here in this area. They start breeding there, and then they start expanding out, and they start grabbing more turf. So these circles represent like territories where you would have breeding pairs or packs. And then, ideally, they just keep going until they stop. And they did at some point in the mid-90s or so. They had some issues with hybridization. And that's where the sterilization technique comes in. So as they were expanding this population out, this is Kilkenny right here. That pack had experienced an introgression event or a hybridization event. One of the males had bred a female coyote, and one of the offspring of that female coyote was able to back cross into the red wolf population. And at that point, some other wolves were pairing up with coyotes out there. So by the time you got to 1999, 2000, you had probably more wolves paired with coyotes than you did wolves paired with wolves, and that was a problem. And so to address that, that's where they came up with the idea of coyote sterilization to prevent introgression. And that came up during a 1999 population habitat viability assessment workshop held in Virginia Beach. That's the PHVA there that you see. And so a bunch of experts came together to discuss what is the best way to manage wolves in North Carolina and to, I guess, combat this threat of hybridization. Part of that group were two individuals, Eric Giese and Fred Knowlton, with Utah State University. They work with the USDA there, and so co-op unit. Fred Knowlton is now retired, and so is Eric, but Fred was a biologist in Texas during the 60s and 70s. So he goes way back with red wolf recovery. And he's a well-known coyote biologist who was looking at the effects that offspring had on, like, coyote behaviors and whatnot. And so they were at Utah State discussing use of sterilization to manipulate coyote populations in terms of management. And they offered this up at the workshop. And so the Fish and Wildlife Service jumped at it, obviously, and realized that this could be a potential useful tool for them. In North Carolina, there's 3 types of canis. This is a red wolf. These are large-sized canids that can range from 50 to 85 pounds. And they represent the historical wolf of the eastern U.S. And then you have coyotes that are moving in now, and these are smaller intermediate-sized canids. They're usually 25 to 40 pounds, and they are representative of the coyote populations that would have occurred in the Midwest. And then, of course, you have your hybrids. And these are also intermediate-sized coyote-like canids. When red wolves breed with coyotes, they create F1, F2 hybrids. They're very coyote-like. They're not big. They don't break 50 pounds very often. I think out of like 250 hybrids that I assessed in North Carolina, I think 3 of them broke 50 pounds. They were big males, and they were basically, red wolf back crosses at that point. They were probably more red wolf than they were coyote, obviously. So most of them are very small and indistinguishable from coyotes. They're usually in the 40-pound range, whereas coyotes tend to be in the 30-pound range. And so out there, when when managing these coyotes and hybrids, the female coyotes get spayed or tubal ligation. Tubal ligations are what they do now. When they first initiated the sterilization technique, they had spayed some of the animals. It's the same thing with male coyotes and hybrids. Initially, they had been neutering some of the animals, and then they switched over to vasectomies. And the reason is they want the animals to be as intact as possible to ensure that they weren't influencing any of their behaviors, because they weren't sure if the sterilization would prevent them from grabbing territories and possibly not breeding. So they want to ensure that they could do that. And so the underlying technique or tenet for the technique is space out there is very limiting for the canids. All the suitable space in the recovery area should be occupied by red wolves. If there are any voids where red wolves weren't occupying, you would hope that you would use the sterilized animals to fill those voids until red wolves had an opportunity to usurp them. And then as the red wolf population increases, these sterile placeholders or sterile animals would eventually be displaced by red wolves, and you would eventually saturate the peninsula with red wolf territories. And the way that works, it's hard to conceptualize that, so I'm just going to try my best to walk you through this here. So this is hypothetical. These are not real locations of red wolf territories. These are just hypothetical spots where you say the peninsula is saturated with red wolf territories. That's good. And then outside that, you have coyote territories, which are these little blue clouds. Now you would have movement going outside. You would have wolves trying to move outside the recovery area, but we're going to ignore that. The idea is that coyotes are going to try to move into the peninsula, and they'll hit a wall of coyote or red wolf territories that should prevent some of them from passing through. Ideally, they would hit those territories and be discouraged from moving further east, so they may turn around and go west. few that go through, of course, would pass through and be looking for other coyotes or open vacant space to take advantage of. They wouldn't find it. They would hit the sound and then would turn around and go back out. And that was that. We did see that, I think, around 2005, 2006, where we had about 18, 19 packs out there. A lot of the animals that were captured and sterilized seemed to bounce out of the recovery area. They couldn't find space. The problem is you need these sort of contiguous mosaics of red wolf territories to really saturate areas to prevent coyotes from coming in. What disrupts that is pack disbandment, and that was what was starting to happen in the mid 2000s. Here you see survival rates, monthly survival rates for red wolves. The one big dip you notice happens in October through December. That's when the whitetail deer hunting season is occurring in the 5-county area, that peninsula. I think it's like October 15th or December 15th is typically when the deer season is occurring. And so you have this influx of sportsmen getting into the woods out there, and they're shooting at stuff, and red wolves get caught up in those situations and they get shot. And so what that does is it breaks up some of the packs and causes them to disband. So in some situations, the packs disappear. Coyotes come in and they establish territories. Other times, and that's what these little blue clouds represent, other times, some of the wolves in that pack will survive and they need a new mate, but because there's no coyotes or there's no red wolves around, they will pair up with a coyote. And so in that situation, you have a red wolf that is currently with a coyote, and that's what these red clouds with a blue dot in them represent. So now you have 3 breeding pairs out there. You have red wolves or red wolves producing red wolves. That's right there with the red cloud. You have coyotes with coyotes producing coyotes. That's the blue cloud. And then you have a red wolf with a coyote, and they would produce the hybrids. And that's what the sterilization technique is trying to prevent. So in this case, they would catch that coyote and sterilize it so that any breeding attempts that would happen in that territory wouldn't happen, because you would have a sterile coyote there. They couldn't produce pups. And because they couldn't produce pups, they weren't producing hybrids that could then back cross into the red wolf population. Coyotes that were caught up and sterilized could pair up with other coyotes. In that case, some of these coyote territories wouldn't be producing any animals either. And that's kind of what we were seeing. This is a paper I published a few years ago showing this. Phase 1 is prior to the red wolf adaptive management plan. And so you can see the first hybridization event occurred in 93, and that's a congeneric pair. That's one of these red wolf territories with a blue dot in it. And that increased to the point by 2000, as I mentioned, we had like 11 of those compared to 6 red wolf packs, which would be these red clouds. They implement the red wolf adaptive management plan. That's phase 2 when it's initiated. And the Fish and Wildlife Service is able to drive down the number of these red clouds with a blue dot into it to about 2 of those. So in this point in 2005, there's 18 red clouds, red wolf packs, and 2 of these red clouds with a blue dot in it. So they were able to drive it down pretty good. But then in 2005, we saw an uptick and red wolf packs disbanding due to human caused mortality, shooting deaths. And then you start seeing more of these sort of congeneric mixed pairs forming. And that sort of stabilized at about 6 due to the sterilization technique and management. So that looks really noisy and crazy, I know, and it may look like the program wasn't succeeding because of this. But I just want to stress, if you compare it to Yellowstone and their reintroduction project, they were doing a good job out there. So red represents the red wolf population from 1988 to 2020. Gray represents the gray wolf population in Yellowstone. So that project started in 95. So you start to see that population increase. Once the red wolf adaptive management plan was activated or implemented from 2000 to 2013 or 14, you see that they had as many red wolves on that peninsula as they had gray wolves in Yellowstone National Park. Both of them suffered some decline in the numbers there. The difference was the red wolf adaptive management plan was terminated in 2014. They stopped sterilizing coyotes at that point. They were issuing some take permits, removing some non-problem wolves from properties. And there was litigation going on. There was political pushback. And so it was a messy time period. I'm not going to get in that soapbox right now. Do that another time. But the point being was the red wolf adaptive management plan was terminated, and they stopped managing coyotes at that point. and the population declined. Whereas, they kept managing wolves at Yellowstone, which is why they sort of maintain 100 animals out there still. The population right now in North Carolina, I think, is about 25 red wolves, and I think they have about 30 sterile coyotes out there. But with the intent of increasing those numbers now, there's been a recommitment to restoring that population in North Carolina, and they're working with the commission on that. Recently, I think there were some resolutions passed that the North Carolina Wildlife Resource Commission is going to work with the recovery program and commit to it. So hopefully good things going forward. But I want to point out, like, there's a ton of negative rhetoric around this program. And a lot of it had to do with the hybridization debates in the early 90s and some of the management of the coyotes. But this program ran really well. The gray wolves were on Yellowstone. That's an area that has very little roads, if any, no hunting. I mean, it's a national park. And these guys are managing red wolves and coyotes across a peninsula that is largely private, that can be hunted. These coyotes can be hunted, deer hunting and whatnot. So you had hunting throughout the peninsula, even on federal lands. A much more difficult situation, and they were just as successful as Yellowstone was in maintaining the number of wolves they did, and they don't get the credit they deserve. So I just want to point that out. So Eric Giese and I think Patricia Terletsky, their spouse, their husband and wife, they published this paper in 2015. So I'm going to refer to as Eric's paper. And they introduced this placeholder concept where the sterilization was used to reduce introgression in the red wolf population. And so what they found was that when they sterilized these coyotes and put them back out, or the hybrids, they grabbed turf and they maintained territories just like fertile animals did. And you can see here on the right of that text, this is all the territories from 2000 to 2013 that had sterile placeholders or sterile coyotes. And this is a photo of a coyote that I caught as a PhD student that we sterilized and put back out down in Rose Bay. They found that placeholders had a slightly higher survival rate than red wolves did. They also reported that 37% of the placeholders were displaced by red wolves. So 2 out of 5 of all these circles and ovals that you see here were broken up due to red wolves. Most of those displacements happen in the winter. Makes sense because that's when breeding's happening. That's when the wolves would be most likely to compete for mates. Males are more likely to be displaced than female placeholders were. And that's because, according to our research that we did for my PhD, your larger males were unlikely to do that. Very few of them could sort of with coyotes. And so it's not surprising that most of these placeholder territories, the wolves that they were interacting with were female wolves. And so it was male wolves going into these territories and displacing males to free up those red wolves. And that seems to be confirmed with other data. So that was a good finding. The other thing too was most displacements happened in areas with low road density. Again, another important thing. Road density means people have access to these territories. They're either going to, drive in and hunt the coyotes, or the coyotes, because they're near a road, could be hit. And so at times humans are killing these animals, and that's freeing up that mate for the wolf to go into and get without a fight. And so in areas where there are very little human influence, the wolves are going in there and actually displacing the coyotes for their mates. And that's a good thing too. And so overall, Eric reported that less than 4% of all the red wolves had any type of coyote in them. Basically, if you took all the red wolf genetics out there in the wild, less than 4% of it was coyote. And that all could be tied back to that hybridization event that happened back in '93 on Kilkenny. And so the sterilization project did a really effective job of preventing backflow into the red wolf population. So their conclusion was that the placeholder concept, or the use of sterilized animals, was great to limit hybridization, but they didn't think it was something that you could use to limit the distribution or size of coyote populations. So they emphasized that this should be used in situation where you had hybridizing species and you want to limit introgression. And that was their conclusion. And then a few years later, Mike and I published this paper looking at the same data set, but from like a broader coyote management viewpoint. Because in my experience out there, I felt like the sterilization of animals could have an impact on coyote abundance. And so I figured, you had all this good data, why not see what happens? And so we looked at it under that context. One of the things we wanted to do was look at where these guys were capturing red wolves, coyotes, and hybrids, and see if that was a difference. Where you would catch a hybrid or a coyote or a red wolf, was there any signifiers in terms of the landscape? One area better than the other. Look at how often they were able to catch them, how many, and like what was the extent of trapping efforts on the 5 county area. Then look at the survival analysis, or look at survival of these three taxa. What Eric did in his paper was he just looked at radio marked animals that were released and not killed by the Fish and Wildlife Service. So his analysis was restricted to placeholders that were holding territories and that were either killed by hunters and trappers or hit by cars or killed by wolves or died naturally. Our analysis for coyotes and hybrids was also to include the Fish and Wildlife Service as a source of mortality. So that's why you'll see some differences in those estimates. It doesn't mean one estimate is more right than the other. We just we used a different sample and still have different estimates there. And then we use that information to try to estimate annual population sizes between 2000 and 2013. The reason why we want to do this is because coyotes are resilient to lethal management. There's a lot of research out there that shows that. One of the things is compensatory immigration, meaning that if you kill coyotes in an area with the intent of lowering their numbers, you start to see new ones show up, and it's not usually due to compensatory breeding. It's usually due because animals are moving in from other areas to occupy those vacancies. What you see here to the right are three coyotes that we sterilized in the 5 county area that left the 5 county area and went elsewhere and settled in somewhere. And this is where the recovery program kind of understood that, like, hey, we're catching coyotes. Only a few of them are going to be pairing with wolves. But if we keep sterilizing a number of these animals that we do have, they may settle with coyotes elsewhere. And since they're sterile, they may actually prevent hybridization, or they may prevent coyote growth in those areas, and maybe will slow the number of coyotes we're seeing in the 5 county area. So conceptually, they were thinking this may have an effect on numbers, and that's why you see a lot of coyotes released and that weren't paired with wolves, but they were released as sterile animals. The other thing too is, a lot of times you go in to find a problem animal and you wind up catching its offspring, or you wind up catching transients. You don't kill the right animal, and so you wind up killing surplus animals, and it doesn't really have an effect. So this is Ben Sachs's work out of California, looking at how breeding pairs are pretty resistant to non-selective removal techniques. And finally, Eric and some others out in Utah were looking at sterilization, and the sterilization was showing some promise in terms of influencing. Eric found that they were able to influence coyote foraging behaviors. So if the coyotes were sterile, they didn't have pups, they didn't have to worry about eating, like they weren't going out and killing fawns. And so they saw that they were focusing more on smaller prey, like small mammals and rabbits. And so in this situation, if you're concerned about coyote predation on ungulate species, you could sterilize them, and the sterile animals would shift their foraging behaviors towards smaller animals because they didn't have to provide any type of food for offspring that they didn't have. Okay, animal captures. So I reduced a lot of the land cover variables down to 3 variables in a PCA, a principal component analysis. PC1, PC2, PC3, PC4 represent the major variation in the landscape regarding those land cover variables. PC1 is contiguous habitat, that's fragmentation. You can see right here, this is Phelps Lakes. This is Lake Matamuskeet, and this is the contiguous bottomland forest for Alligator River and Adair County bombing range. Everything else that has lower PC scores here are areas that are more fragmented. This is a large agricultural area, so it has like more contiguous, so it's a higher PC score. So basically fragmentation. PC2 had to do with biomass and vegetation density. So areas with red tend to be areas like, Matamuskeet, like Phelps, and its agricultural area, low vegetation density. Areas that are blue have lots of vegetation density. This is elevation, so areas in red are higher in elevation, drier areas. And PC4 is road density, or distance to roads. So areas that are in blue, you can see these little linear corridors there, those are roads. And so areas in blue, lots of roads, close to roads, whatever. Areas in red are further from roads. So the 4 main landscape cover characteristics out there was fragmentation, vegetation biomass, elevation, and roads. And so when we overlay the captures on these layers and extract those values and model them using generalized linear mixed models, we could see, we could compare where where the Fish and Wildlife Service was catching red wolves, coyotes, and hybrids. Regarding fragmentation, they were catching more coyotes in areas that were highly fragmented compared to red wolves. Red wolves tended to be in areas that were more, I guess, yellow and green. So a little more contiguous. Coyotes were in areas that were more like blue to green, areas that are a little bit more fragmented. So coyotes were coming in here and moving up through the north there, down through the south. Red wolves are more likely in these green areas around the agricultural areas. Regarding PC2, they were all kind of the same. None of these animals really liked areas that had high vegetation density. They preferred more open habitats. Same thing with elevation. All three preferred areas or captures were happening where you had drier ground. And finally, this negative coefficient means they're closer to roads. So if you're on a road, you get a 0. If you're further from a road, you get 100 meters or 1,200 meters or something like that. So roads tend to be negative coefficients are good things for selection for roads. So the recovery program was catching more animals in these blue areas where you had road networks and whatnot. So basically, they went where the wolves where the wolves and coyotes were. So from research, we know that these animals tend to establish their territories on cropland forest edges. And that's where the biologists went to catch them. And that's where they were most successful at. I mean, it sounds like, circular reasoning, but what's important here is how they did it. So of all the captures that they have gotten out there in terms of red wolves and coyotes, 91% of them came from the Fish and Wildlife Service. So there's private trappers out there, and they will sell their coyotes or their hybrids to the Red Wolf Recovery Program. The recovery program would then sterilize those animals and release them. And so that was the other, I guess, 7 or 8% that you see there that the Fish and Wildlife Service wasn't accountable for. Based on the trap line data that I had and the distribution of all the captures, the recovery program covered 63% of the peninsula in terms of their trapping efforts to get animals up. So they covered a lot of that peninsula over that 13-year period. They captured 1,252 animals. About 45% of them were recaptures. So that's a good sign that when the recovery program needs to go get an animal, they can go get an animal. They can do recaptures, no problem. And what the high recapture rates indicate, and over time, was that the biologists were able to acquire a lot of information about how the animals use the landscapes. And they had a lot of prior information from the radio-collared animals, the territories, and just institutional knowledge of how canids were used in the landscape there. And that always increased their probability to do a good job going into areas and getting animals up. And so when people oftentimes criticize, that this is very tough, you're going to go catch all the animals, how are you going to do that out there? The program had been doing it and they were doing a good job of it for quite a time, period. And if you had to give them the chance to do it again, I'm sure they would be able to do the same thing. They were very efficient. I haven't seen that type of effort or similar success or whatever outside that 5-county area. I've done work in Georgia, South Carolina, where else? Mississippi, Alabama, Louisiana. Yeah, lots of good work elsewhere, not replicating what you see in that 5-county area. Regarding duration and sources of mortality, about half of the coyotes and hybrids that were captured were released as sterilized animals. So they were euthanizing a lot of animals up front. Over time, that became less frequent. Hybrids were the ones who got euthanized most often than not. And about 80% of all the sterile animals remained in the recovery area. So about 20% loss of animals leaving. Most of the animals were monitored for about 2 years before they were either removed by the Fish and Wildlife Service or displaced by red wolves. Of the 535 that were captured, the overwhelming cause of death was human caused. The Fish and Wildlife Service was responsible for about 3/4 of all those deaths. But once they were the ones that were radio marked and sterilized and released back out, their survival, human caused mortality obviously dropped for them. The recovery program was responsible for about 2 out of 5 of their deaths in terms of removing them to create space for red wolves. Hunters and trappers were responsible for about 1 out of 5 deaths. Sorry, my computer's freezing. There we go. Roadkill, 1 out of 10 deaths. Red wolves were responsible for 1 out of 10 deaths, and then unknown deaths were 1 out of 5. So it all works out to be 5 out of 5 there. And so that's the breakup there. And some other little tidbits: red wolves are more likely to be shot to death than were sterile animals, probably because they're larger and they're using agricultural areas that are harvested and out in the open during the fall when the hunters are out there. Red wolves are more likely to be hit by cars than were coyotes. Again, a lot of these wolves move around quite a bit and probably cross more roads than coyotes do for that reason. There's just a higher risk for them. And finally, I thought sterilization likely reduced intraspecific strike between red wolves and coyotes. So in situations where the Fish and Wildlife Service felt they had to go in and clear out a placeholder, they were taking that opportunity away from the wolf. And so instead of a wolf displacing that animal, the Fish and Wildlife Service did it for them. They interfered with it. And other times where you had sterile placeholders adjacent to red wolf territories, they weren't producing offspring. So you didn't have the opportunity of naive pups crossing into wolf territories and getting killed by wolves. And so under natural conditions, I would assume this interspecific strife would be a lot greater. Annual survival rates, 0.67 was the annual survival rate for red wolves. 93% of the red wolf population was known to the red wolf program, meaning that out of every 100 wolves that were out there, they had touched and managed 93 of them. From 2000 to 2011, 12, 13, we had between 102 and 151 red wolves. Our survival rate was lower than what GIWFC provided. Again, this is because we included pups. The first time wolves are marked, I realize we're getting close to, well, I gotta get off here in a minute. We accounted for pup survival. Eric didn't, and so that's why survival is lower. For coyotes, my computer's freezing up. Yeah, survival was 0.54%. Again, of the coyotes out there, the Red Wolf Recovery Program during that time period had encountered and managed 47% of them. We found abundance estimates ranging between 15 and 129 coyotes. Again, lower because Eric didn't account for the Red Wolf Recovery Program's removal of placeholders. We did, and so we found that coyotes had, basically the recovery program had reduced survival down by 30 percentage points. Same thing with hybrids, 0.7 for survival. Out of all the hybrids that were out there, the recovery program touched or managed 30% of them. Abundance between 44 and 67, and then they had lower survival rates for the same reason. We included the recovery program removing them lethally. So here's the population estimates. What we're concerned about is from 2000 to 2013, red wolves going from 102 to 151 down to about 120 or so. Coyotes saw a big uptick after 2005, and then hybrids were consistent at about 30 animals. Of all those animals during that time period, 71% of them were radio marked by the Fish and Wildlife Service. The bulk of them being red wolves. Remember, 93% of these animals up here in the black line were radio marked. 29% of the remaining animals were probably fertile coyotes and fertile hybrids that contributed to the abundance of these animals. But immigration was probably the primary source for the coyotes, just moving in. And this time period in 2005, we see a big uptick in human-caused mortality in red wolves. And so it's not a surprise at that time we start seeing more coyotes move in. Between 1987 and 2004, this time period right here, about 24% of all the red wolf deaths were shooting deaths, and that doubled from 2005 to 2013. We also saw increases in hazard and instances of poaching from 87 to 2000. So this period, we just see a big uptick in human-caused mortality with red wolves, the spam in the packs that creates the openings for the coyotes to come in. And so when we compare our density estimates down here, 2.5 to 21.5 coyotes per 1,000 square kilometers, to other studies done elsewhere, we find that it's lower, particularly this Yukon territory up in northwest Alaska, where it's like the northernmost limits of coyotes. Our estimates there are lower. Savannah Riverside's just ridiculously high because they kill the hell out of the coyotes there, and that's artificially inflated due to compensatory immigration into that area. But in general, we see very similar lower densities of coyotes in the 5-county area here. Looking at this is my last slide before I conclude. This is the habitat use of coyotes in the 5 county area based off radio collaring that we did. It's very similar what the red wolf habitat selection is. So areas in red are good for packs, yellow too. Blue areas they're not going to use. And so they're not using everything out there. So when it comes to this question of how many coyotes can the North Carolina recovery area contain or hold without sterilization and or red wolves, this is going to be a back of an envelope estimation on my end. I'll walk you through it. I'll say 500 to 700. And that has to do with where they can establish their territories. So this area in red and yellow is estimated to be about 360 square kilometers out of the 6,000 square kilometers is usable. Coyote home ranges are usually about 7 square kilometers. Red wolves are about 68 square kilometers. During 2009 to 2008, this is where I'm doing this estimate from. The recovery program managed 20 sterile territories, 12 coyote territories and 8 congeneric territories, meaning that you had 30 sterile coyotes in those 20 sterile territories. And then you had 16 red wolf territories out there. If you add up that space that they occupied, about 550 square kilometers were occupied by sterile animals. So that space is not producing coyotes. It's not producing anything, hybrids or nothing. The other 1,100 square kilometers that had red wolves in them were producing red wolves. Collectively, that accounted for about 45% of that 3,600 square kilometers. And that came out to be about 12 coyotes per square kilometer. Per square 1,000 kilometers in terms of sterilization. If you eliminate wolves and you eliminate sterilization, that area would hold 60 coyote packs with 2 breeders, estimating 4 offspring. That would be about 360 coyotes. So without wolves and without coyotes, you would have about 220 coyotes per 1,000 square kilometers, which is about the size of a county. So that's 220 coyotes per county. In the case of sterilization and red wolf presence, it would be reduced to about 12 coyotes per county. Based on my experience out there, it's probably 500 to 700 coyotes because you work out the math here with 220 per county. It's about 800 animals. I think it's a little bit too high. And so I brought it down to about 500 to 700 coyotes. And that's what I think the peninsula would hold without red wolves and without sterilization. If you remove red wolves and you use only sterilization, I would estimate you could probably reduce 500 or so animals down to about 200, 250. So you could probably halve it because sterilization is not going to remove coyotes from the peninsula. If you want an absence of coyotes on the peninsula there, you have to saturate it with red wolf territories because where you have red wolves breeding with red wolves and holding that space that excludes coyotes, you get 0 coyotes in those territories.